Hello everyone, good afternoon to all. So all of you are welcome here in this problem solving session. Okay, uh, we are just going to give you a recorded session on the solution of session 1 of 28th January. So today I'm just going to discuss the solution of JEE Main paper which was held on 28th of January in session 1. We are only going to discuss that physics section here. So the very first question you can see on your screen, a block of mass 5 kg is moving on an inclined plane. So on an inclined plane which makes an angle of 30 degree with the horizontal, frictional coefficient between the block and the inclined plane surface is square root of 3 by 2. The force to be applied on the block so that the block will move down with an acceleration, okay, will move down without an acceleration is. This is the question. If there is no acceleration, we can easily say there is not any force acting, right? Suppose this is the inclined plane. I have drawn this inclined plane. Now there is a block over it, capped. Yeah, okay. If I draw the weight of it acting through the center of gravity, this is the weight, mg. Going to have two components, one that is parallel. Suppose inclined plane is inclined at an angle theta. Inclined plane is inclined at an angle theta. So there are two components, one that is mg cos of theta and the another one which is mg sine of theta. Okay, this is the force. Now the normal reaction, okay, it is balancing the normal component of the weight. Okay, the component which is normal to the inclined plane and opposite to the, okay, so there is a normal reaction. This normal reaction is acting opposite to mg cos of theta. Okay, so I can just write n is equal to mg cos of theta. Now you can write force of friction. Okay, force of friction, that is equal to, if I write limiting friction, this is equal to mu into mg cos of theta. What is that mu? Mu is the coefficient of static friction. Okay, and there is only one given and it is a square root of 3 by 2. So you can write this limiting friction as square root of 3 by 2. You can write the mass. Where is that mass? It is of 5 kilogram. G, that is of 10. Cos of theta. Okay, so this theta angle, that inclination, angle of inclination is 30 degree given to us. So you can now just write cos of 30 degree. So this limiting friction is actually equal to square root of 3 by 2 into square root of 3 by 2 into 5 into 10. Okay, so this limiting friction, if I calculate it, limiting friction, if we calculate it, that is 3 by 4 into 50. And if you make a calculation, so 150 by 4, okay, then you will get 37.5 Newton. This is the limiting friction. If I check this mg sine of theta, this is the driving force, right? Which can take it down. So mg sine of theta, if you calculate it, so 5 into 10 into sine of 30 degree. Sine of 30 degree is 1 by 2, so 5 into 10 into 1 by 2. So you will get 25 Newton. Okay, that driving force is 25 Newton, and we can see this driving force is obviously less than the limiting friction. So it cannot go down. Okay, if no force you are applying, it cannot go down because this mg sine theta is being balanced by that friction, and friction we can say at that point of time is just 25 Newton, not that limiting friction. What if I want to push it down? Okay, so I have to apply some force in the downward direction. Suppose that force is F. Okay, suppose that force, this force is F. Now because no acceleration is there, you can write this force F, this mg sine theta, okay, that is actually equal to the limiting friction. So you can write this driving force plus this force F is actually equal to limiting friction. For no acceleration, this is the condition. Now you can write Fd driving force, which is 25 plus F is equal to 37.5. And this force applied, force required so that it can be pushed without an acceleration down the inclined plane, it is actually equal to 12.5 Newton. So third option is the correct one. Third option is the correct one. Now the next question, question number 27. Given below are two statements. Given below are two statements. Statement 1, a plane wave after passing through prism remains as plane wave, but passing through a small pinhole may become a spherical wave. Statement 2, the curvature of a spherical wave emerging from a slit will increase for increasing slit width. These are the two statements. In the light of the above statements, choose the correct answer from the options given below. Now the first option, both statement 1 and statement 2 are true. Option 2, statement 1 is true, but statement 2 is false. Option 3, statement 1 is false, but statement 2 is true. And the last option, okay, the last option is both statement 1 and statement 2 are false. So let's check the validity of the first statement. What is that? A plane wave passing through a prism remains as plane wave, but passing through a small pinhole may become a spherical wave. Okay, so suppose there is a prism, that equilateral prism, and if there is a wavefront falling on it. Suppose this is the wavefront falling on it. It is moving towards this prism. Okay, it is moving towards this prism. After going through this prism, this wavefront, okay, gets tilted. Why it gets tilted? Okay, in this way. The upper part is in the forward, okay, that is inclined more, okay, so you know upper part is ahead than the lower part. Because the upper part is covering less distance in the prism than the lower part, okay. So this wavefront when coming out of the prism remains a plane one, okay, but a tilted one. So in the statement 1, a plane wave after passing through a prism remains as plane wave. This is correct. Second part, okay, second part of this statement only. But passing through a small pinhole may become a spherical wave. This is also true. Suppose there is a plane wave front. Okay, there is a plane wave front and it is falling on a slit. Suppose this is, okay. Suppose this is a slit here. And there is a plane wavefronts. Plane wavefronts are falling. Parallel plane wavefronts are falling. Okay. Then through this slit, okay, each point on this slit, that will start acting as secondary wavelet. Okay. And there is you will get spherical wavefronts from it. So this statement, the first statement is fully true. Okay. Statement 2, the curvature of a spherical wave emerging from a slit will increase, the curvature of a spherical wave emerging from a slit will increase for increasing slit width. What will happen? Okay, what will happen if you increase the slit width? If you increase the slit width, suppose you increase the slit width, then those parallel wavefronts coming towards this, okay, parallel wavefronts coming towards this, that radius of curvature will actually increase. Okay, it will keep on increasing. As you will keep on increasing the slit width, this will keep on increasing. Radius of curvature will keep on increasing. Okay, what I'm not saying only at that place, here at the slit, this radius of curvature will increase. I'm not saying it is increasing with the distance, it will itself increase here. Now suppose there is no, as soon as you are, okay, if you are going to increase that slit width, it means that the transmitted wave front, okay, the wave front corresponding to transmitted wave through the slit will going on becoming parallel. So this radius of curvature will keep on increasing. If radius of curvature is increasing, that curvature is actually decreasing. Okay, the less is the radius, more is the curvature there. Okay, the less is the radius, more is the curvature. If you have a sphere of infinite radius, that is almost a plane and there is no curvature. Now the next question, so in the previous one, statement 1 is true, okay, statement 2 is false, curvature is not increasing, that is decreasing. So statement 1 is true, but statement 2 is false, this is the correct option. Now the next one, what is that next one? Next question you can see, the magnitudes of power of a biconvex lens. The magnitudes of power of a biconvex lens, refractive index 1.5, and that of a plano-concave lens, refractive index equal to 1.7, are same. If the curvature of plano-concave lens exactly matches with the curvature of back surface of the biconvex lens, then the radius of curvature of front and back surface of the biconvex lens is. So suppose this is the biconvex lens. This biconvex lens is having radii of curvature as R1 and R2. What about this plano-concave lens? Okay, so this plano-concave lens, this is the plano-concave lens, and plano-concave lens is having the same radius of curvature as the backside of this convex lens is having. So you can write focal length of this convex lens. Okay, let me call it f1. That 1 by f1 is actually equal to refractive index mu minus 1. Okay, refractive index mu minus 1 into 1 by r1 minus 1 by r2. Okay, by using this formula I can write r1 you can take as plus r, but r2 you can take as minus r2. Okay, so if I put with the sign 1 by f1, it is equal to mu minus 1 into 1 by r1 plus 1 by r2. Okay, now according to the question, the magnitude of powers of biconvex lens and that of plano-concave lens are same. Okay, so this is basically, okay, this is actually giving me the power. So this power P1 is equal to mu, okay, let me take refractive index as mu1. So mu1 minus 1 divided, okay, into 1 by r1 plus 1 by r2. Mu1 minus 1 into 1 by r1 plus 1 by r2. Now if I write the power for this plano-concave lens, so I can write this P2. Okay, you can write here P2 is actually equal to mu2 minus 1 into, okay, in place of R2 I will write this minus R2. Okay, in place of R1 I will write minus R2, in place of R2 I will write infinity. So minus of 1 by R2 minus of 1 by infinity, and you can get this P2 is actually equal to mu2 minus 1 into minus 1 by R2. Now you can write this P2 is actually equal to minus of mu2 minus 1 divided by R2. 1 by infinity is 0. Okay, that 1 by infinity is 0. If you put P1 equal to P2, so P1 equal to P2, if you put P1 equal to P2, that is mu1 minus 1 into 1 by R1 plus 1 by R2, that is equal to minus of mu2 minus 1 divided by R2. Now what is that? Mu1. Okay, so mu1 according to the question is 1.5, mu2 is 1.7. So 1.5 minus 1, okay, into this 1 by R1 plus 1 by R2, that is equal to, with a negative sign, 1.7 minus 1, 1.7 minus 1 divided by R2. Okay, so we have 0.5 into 1.R1 plus 1 by R2 is equal to minus of 0.7 divided by R2. You can also write this 1 by R1 plus 1 by R2. Okay, that is actually equal to minus of 7 by 5 R2. Okay, this you can write. Or what you can do, you can just multiply. Okay, you can just multiply on the right side by R2. You can just multiply on the left side by R2, and you can write R2 by R1 plus 1 is equal to minus of 7 by 5, or this R2 by R1, okay, is actually equal to minus of 7 by 5 minus 1. Okay, one second, let me just check this. Mu2 minus 1, mu2 minus 1 by R2. Okay, that is fine here. Here I am also writing with the sign convention. Powers are equal. Okay, with the curvature back surface of the, then the ratio of radius of curvature. Powers are equal. Powers are equal. I am assuming that powers are equal in magnitude. So you should write mu2 minus 1 by R2 is actually equal to this. Mu1 minus 1 into 1 by R1 plus 1 by R2. You should take only the magnitude into account. So take it positive. Okay, if you take it positive, yeah. Now R2 by R1 is just equal to 2 by 5. What they are asking? Then the ratio of radius of curvature of front and back surface. So front is R1, back is R2. R2 by R1 I have calculated is 2 by 5. This implies R1 by R2 is actually equal to 5 by 2. So 5 to 2 is the ratio. Okay. Now see this question. In the potentiometer, when the cell of secondary circuit is shunted with 4 ohm resistance, the balance is obtained at the length of 120 centimeter of wire. Now when the same cell is shunted with a 12 ohm resistance, the balance is shifted to a length of 180 centimeter. The internal resistance of cell is. So if you draw the circuit of a potentiometer, okay, so there is a wire connected, a resistance connected here, a resistor connected here. There is secondary one, okay. So in the secondary cell, there can be a battery. Battery can have an internal resistance, okay. There is a galvanometer connected. Okay, this is the galvanometer acting as an ammeter actually. There is a galvanometer connected. Okay, and it can touch. Okay, it is in contact somewhere. It can, okay, it can touch this wire somewhere. Suppose this point is E, right? This length you can measure. So because of this primary battery, because of this primary circuit, there can be a current through it. Okay, there can be a current through it. When the potential difference across the terminal of the battery becomes equal to the potential drop across this segment. Let me call this segment to be AB. Okay, in that case, there will be no deflection in the galvanometer. This is the idea. So what is happening here now? First of all, the secondary circuit is shunted with a 4 ohm of resistance. Okay, so secondary circuit is having, suppose that battery is having an EMF E dash. Okay, so I'm just going to draw here the secondary circuit. The secondary circuit will look like this. Internal EMF of the battery, then there is a 4 ohm of resistance, right? This is small r, this is 4, this is E dash. If I write what is the voltage difference across the terminals of the battery, so first you need to find out the current I, and it is equal to E dash divided by 4 plus small r. EMF, okay, voltage difference across the terminals of the battery. Let me write it as V. That is given by E dash minus of I into small r. So this V is equal to E dash minus small r. So V is actually equal to E dash minus IR. Okay, so you can write here E dash minus current, which is E dash divided by 4 plus small r into r, and now you can write 4 E dash plus E dash r minus E dash r divided by 4 plus r. Okay, that is the voltage difference across the terminals of the battery. Cancelled out. So you are left with across the terminals of the battery, voltage difference is 4E dash divided by 4 plus R. Let me call this V1. Okay, let me call this V1. Similarly, you can write V2. Okay, that V2 is actually equal to 12E dash by 12 plus R when it is being shunted. When the secondary circuit is being shunted with the resistance of 12 ohm. Okay, now you can write this V1 by V2 is actually equal to L1 by L2, right? Because current I is going through this. Okay, this primary will give a current I to it. If you multiply this current I with the with this length, okay, suppose that balancing length is L1 in the first case, then V voltage drop across the terminal of the battery, which is V1, is equal to I into L1. In the second case, it is I into L2. So I can write V1 by V2 is equal to L1 by L2. If you see this V1 by V2, if I do, what you are going to get? You will get 1 by 3. Okay, you will get 1 by 3. So I am skipping some steps. 12 plus R divided by 4 plus R. And it is equal to L1 by L2. What is that L1? Okay, so L1 is 120 centimeter and L2 is 180 centimeter. So you can write 120 divided by 180. This is 2 by 3 is equal to 1 by 3 into 12 plus small r divided by 4 plus small r. 3 and 3 cancelled out. 8 plus 3r, that is equal to 12 plus small r. Now you can get 2r is actually equal to 4 and R is equal to 2 ohm. Okay, so this is the internal resistance. Okay, 2 ohm. Okay, but I am not finding that. Just one second. 3, 4, 12, 6. Okay, some calculation mistake is there. Let me find out that. Okay, so E dash, okay, 4R, 4 plus R. E dash minus E dash divided by what I'm calculating, voltage difference across the terminal of the battery. So when I will take 12R, then you will get 12 into E dash divided by 12 plus R. This is correct. 1 by 3, okay. E dash cancelled out, you will have 1 by 3, then you will have 12 plus R divided by 4 plus R. And it is equal to 120 by 180, 2 by 3, 3 cancelled out, then 2, 8. Okay, here it is 2R, not 3R. 2R. Now you can write this R is actually equal to 4 ohm. Okay, so this is how you can find out the internal resistance. Okay, this is how you can find out the internal resistance. Now next question, question number 30. Water drops fall from a tap on the floor 5 meters below at regular intervals of the time. The first drop strikes the floor. When the sixth drop begins to fall, the height at which the fourth drop will be from ground at the instant when the first drop strikes the ground is. Okay, so how you can solve this question? So suppose there is this pipe. Okay, when the first drop is falling, they are falling at regular interval of time. So when the first drop is touching the ground, here the drop is actually sixth one. Okay, so suppose this first drop is falling in t equal to 0, okay, at t equal to 0 instant. At t equal to 0 instant, first drop starts falling. At t equal to 0, first drop starts falling. First drop starts falling. Time of fall, because it is falling just from the 5 meter height, that time of fall is actually equal to square root of 2h by g, which is square root of 2 into 5 divided by 10 here. It is square root of 1 or 1 second. Okay. So after 1 second, from t equal to 0, first drop reaches the ground. Okay. So you can see that sixth one is actually being, okay, it is emerging from the pipe at t equal to 1 second. At t equal to 1 second, this is the position. At t equal to 1 second, first drop is reaching the ground while sixth is emerging. Okay. So I can divide the time interval into 5 parts. Okay. There is this first drop, let us say it is touching the ground. Then there is sixth one. Okay, so fifth one, which has been generated. Then there is fourth one. Okay, and there is third one. And okay, let me take here the first one. And there is a second one. So this time interval I can divide into 6th, 5th, 4th, 3rd. Okay, this is 4th one. Into 5 intervals. Okay. The time gap between each of the, okay, 6th, 5th, 4th, 3rd and 2nd. Time gap between each of the consecutive drops, okay, that time gap delta t is actually given by this 1 by 5, which is equal to 0.2 second. Okay, so when the fourth one, okay, when the fourth one is here somewhere, okay, fourth one, okay, sixth, this is suppose first one, then there is second one, then there is third one, suppose here is the fourth one, okay, and here is the fifth one. Space may differ, okay, okay, space can differ between them, space is not same. In respect of time, the interval is same, but not in respect of the distance. In respect of the height, the time, okay, the interval is not same. So the time gap between 6th and 5th, okay, it is equal to 0.2 second. Then again it is 0.2 second. So total time gap, it is 0.4 second. In this time gap, the fourth one, how much height, okay, how much displacement in the downward direction it has taken. That displacement, let me write as 1 by 2 into g into t square. That is 1 by 2 into 10 into that t square, which is 0.04. So 0.02 into 10, this comes out to be 0.2 meter. Now the height from the ground is actually 5.0 minus 0.2, and this is 4.8. This is one second. We are trying to calculate this one. Okay. Yeah. So 1 by 2 into 10. So this is 5 here. 5 into 0.04. Okay. 5 into 0.04, that is 0.2. But the height is 5 meters, so it must be, okay, something is wrong here. 1 second, then 6th one here, 5th one here, 4th one here, then this is the 3rd, 2nd and 1st. So it has traveled through 0.2, 0.2, which is 0.4. So if you make a square of it, that is 0.16. Okay, so calculation mistake is there, 0.16. 0.16 divided by 2, that is 0.08. So you will get 1 by 2 into 10 into 0.16. 0.16 divided by 2, that is 0.08 into 10, it is 0.8 meter. And the height of fourth drop from the ground is 4 minus 0.8, which is, okay, 5 minus 0.8. So that height of the fourth one from the ground is 5 minus 0.8 meter, which is 4.2 meter. So 4.2 meter, that will be the right option. Now the electric field of an electromagnetic wave traveling through a medium is given by E equal to, okay, E vector, that is given by 25 sine of 2.0 into tan raised to the power 15 t minus tan raised to the power 7 x n cap. N cap is the unit vector in the direction of electric field. Then the refractive index of the medium is, okay, so what is that? This is omega. What is this? This is K. If you write velocity in that medium, it is equal to omega by K. Omega is 2.0 into tan raised to the power 15. K is tan raised to the power 7. So this is 2.0 into tan raised to the power 8 meter per second. Now if you write the refractive index N, that is C by V, and this is equal to 3.0 into tan raised to the power 8 divided by this 2.0 into tan raised to the power 8. This is actually equal to 1.5. Okay, so 1.5 is the refractive index. Next question. In the following PV diagram, the equation of a state along the curved path is given by V minus 2 whole square equal to 4 AP, where A is a constant, the total work done in the closed path is. Okay, so you can see this closed path here. This is the closed path. Now the work done, I can say, is actually this area of closed path, closed curve, this area. Okay, that is going to give me the work done. and that work done will be obviously negative, okay, because this loop, okay, you know that sense of rotation, if you move around this loop, it is of anti-clockwise, okay. Finally, you can see that volume is actually decreasing from C to A, okay. So work done is negative. How we are going to find out that? How we are going to find out that? If you see this rectangle, okay, AC, and this is point B, let me take, okay, this is here the value of V is equal to 1. So this is V1 equal to 1 meter cube. Here V2, that is equal to 3 meter cube. This is A, this is C, this is B. Let me take them as D and E. So if you write the area of rectangle ADEC, okay, how much that area? Okay, that area A1 is actually equal to AC multiplied by that height, AD. AC into AD. AC into AD. What is that AC? AC is the change in volume, and it is equal to V2 minus V1, which is equal to 2 meter cube. So 2 into AD. Okay, 2 into AD. What is that A? A point correspond to? Okay, so the value of PA. So value of PA, that is equal to, okay, value of PA, or let me, okay, call it PA according to this relation. You know that from this relation I can write P is actually equal to V minus 2 whole square by 4A. Okay, pressure at A, you should put V equal to 1 meter cube here. Okay, so pressure at A, that is 1 minus 2 whole cube. Okay, 1 minus 2 whole square divided by 4A. Okay, and this comes out to be minus 1 square, that is 1 by 4A. If you put in this V equal to 3 meter cube, which is the value of volume at E. Okay, again you will get the pressure at E equal to 1 by 4A. Now if you calculate this area of the rectangle, okay, that area A1 is nothing but AC, that is 2, okay, into this 1 by 4A. So this is just equal to 1 by 2A. This is A1. If you calculate now this area here, suppose you calculate this one. If you calculate this area, what you need to do? This is area under the curve for a parabola. Equation is this, V minus 2 whole square. Okay. So what I can do? I can just write, let me write here itself. The area under the curve, okay, A2 is actually PdV. Okay, I will write PdV. V is changing from 1 to 2. V1 equal to from 1 to 3. V2 equal to 3. Okay. What is that P? In place of P, I can write V minus 2 whole square divided by 4A. So you can write V minus 2 whole square, area A2, that is V minus 2 whole square divided by 4A into dV. Okay, this V1 equal to 1 to V2 equal to 3. Now you can write this A2 is actually equal to 1 by 4A into this V minus 2 whole cube divided by 3. V is changing from 1 to 3. Now you can have 1 divided by 12A. V minus 2 whole cube. Okay, so 3 minus 2 whole cube, that is 1 cube, minus 1 minus 2 whole cube. Okay, so this is going to give me minus 1. Okay, so you can have 1 by 12A, 1 minus minus 1, minus plus, that is 1 by 12A into 2. So this is 1 by 6A. Now you can write this work done is actually equal to A1 minus A2. This A1 is actually equal to 1 by 2A and A2 is 6A. If you take 6A as the LCM, that is 3 minus 1 it is 2 by 6A, and this comes out to be 1 by 3A. That is only the magnitude of the work. I have told you because it is anti-clockwise, you should take a minus sign with it. So the first one, okay, first option is the correct one. Now the next one, which of the following best represents the temperature versus heat supplied graph for water in the range minus 20 degrees Celsius to 120 degrees Celsius? So at minus 20 degrees Celsius, water is ice. When you start increasing the temperature, it will take heat up to 0 degrees Celsius to increase its temperature. And at 0 degrees Celsius, it will start melting. And their temperature is actually constant. Okay, so the first the temperature will increase from minus 20 to 0. Okay, minus 20 to 0. So let me see here. From minus 20 to 0, that temperature is increasing. Then temperature becomes constant where ice is melting. Okay, after the full melting of ice, okay, after the complete melting of the ice, temperature starts increasing according, okay, to this path. Okay, okay, here temperature starts rising up to 100 degrees Celsius. Then again temperature becomes constant, and the water starts getting change its phase into steam, and temperature is constant. Then again the temperature will start rising to this. So the second one, okay, is the correct option, not this one. Here you can see from minus 20 to 100, temperature is just increasing. Okay, but there is a flat portion comes. There is a flat portion comes where temperature is actually constant and their phase change is actually taking place. The magnetic field at the center of a current carrying circular loop of radius capital R is 16 microtesla. The magnetic field at a distance x equal to square root of 3r on its axis from the center is. So suppose this is the current loop. This is the current loop. From the center of it, there is a point on its axis at a distance x. Suppose it is having a radius r, current through it is I, then you can write at this point P, magnetic field B is equal to mu naught into I into r square divided by 2 divided by x square plus r square raised to the power 3 by 2. Okay, if you write the magnetic field at the center at O, you can write that magnetic field at O is actually equal to, for this point, for the center axis actually equal to 0, you can write mu naught into I into r square divided by 2 divided by r square raised to the power 3 by 2, and you can get mu naught into I into capital R square divided by 2 divided by r cube, and this is just equal to mu naught I divided by 2r. This is the magnetic field at the center. If you want to find out magnetic field at point P, for the magnetic field at point P, you should take x equal to 3 square root of 3r. If you make a square of that x, you are going to get 3r square. Now you can write mu naught into I into r square divided by this 2 divided by this 3r square plus r square, okay, raised to the power 3 by 2. Now you can write mu naught into I into r square divided by 2, 4r square raised to the power 3 by 2. So mu naught into I into r square divided by 2. This 4r square is having a square root of 2r, cube of it, that is 8r cube. So mu naught into I divided by 2r into 1 by 8. Now the value of this mu naught I by 2r, that is equal to BO. And BO is actually 16 microtesla. If you put here 16 and divide it by 8, you are going to get 2 microtesla as your answer. So 2 microtesla is the magnetic field at point P. Next one, 3 long straight wires carrying current are arranged mutually parallel as shown in the figure. The force experienced by 15 centimeter length of wire Q is. First of all, force between these two, force between P and Q, that is a repulsive one. So force on Q due to P is towards right, and because of R, that is again right. Okay, so let me call this force as F1, the second force as F2. Force F1 is the force acting on Q due to P, okay, on that 10 centimeter length there. saying. So F1 is actually equal to mu naught into current in IP, current in Q, divided by 4 pi, okay, and divided by this distance, okay, divided by 2 pi, not 4 pi, 2 pi, and divided by this distance d1 if you calculate it, and the length of that segment, okay. So if you calculate mu naught by 2 pi, that is 2 into 10 raised to the power minus 7. IP, this is 3 ampere. IQ, that is 1 ampere. D1, this is 3 centimeter. 3 into 10 raised to the power minus 2. L1, okay. So length, force experienced by 15 centimeter length. So 15 into 10 raised to the power minus 2. Cancelled out, okay. Now you can have 3 and 3 cancelled out. 15 into 2, that is 30, okay. 30 into 10 raised to the power minus 7, or 3 into 10 raised to the power minus 6 Newton is the force acting. What is F2 if I calculate? This F2 is actually equal to mu naught into IQ into IR divided by 2 pi divided by D2, okay, into that length L. So mu naught by 2 pi, that is 2 into 10 raised to the power minus 7, IQ is 1, IR is 2, D2 that is 2 centimeters, so 2 into 10 raised to the power minus 2 into 15 into 10 raised to the power minus 2. If you calculate it, 2 and 2 cancelled out. So 2 into 15, that is 30, 30 into 10 raised to the power, okay, this is minus 2, it is cancelled out. So 30 into 10 raised to the power minus 7, again the same force is acting. Okay, so this is equal to 3 into 10 raised to the power minus 6. Total force acting, okay, net force is F1 plus F2, and this comes out to be 6 into 10 raised to the power minus 6 Newton towards R. Okay, and that is the right answer. Next question. An atom 3x8 is bombarded by shower of fundamental particles, and in 10 seconds, this atom absorbs 10 electrons, 10 protons, and 10 neutrons. The percentage growth in the surface area of the nucleons is given by, okay, is recorded by. So in the first case, number of nucleons equal to 8. In the second case, number of nucleons equal to 8, okay, 8. And absorption of 10 protons and 9 neutrons is also there. Okay, so this is 8 plus 9 plus 10, that is 27. You can now write R1, okay, because radius is just equal to RO into A raised to the power 1 by 3. Now you can write this R1 by R2 is equal to A1 raised to the power 1 by 3 divided by A2 raised to the power 1 by 3. A1 by A2, that is 8 by 27 raised to the power 1 by 3. If you take a cube root of 8, that is actually equal to 2. Cube root of 27, this is 3. So 2 by 3. R1 by R2, that is equal to 2 by 3. Now the surface area in the first case, okay, that is just equal to 4 pi R1 square. Let us take R1 to be as 2x. In that case, R2 is actually equal to 3x. So 4 pi R1 square, A1 is, and this will give me 4 pi into R1 square is 4x square now, so 4x square. So that is just 16 pi x square. Likewise, you can calculate A2. This is equal to 4 pi into R2 square. R2 square is 9x square. So this is just 36 pi x square. If you see the change, okay, percentage growth. So A2 minus A1 you do, okay. You calculate A2 minus A1. A2 minus A1, that is just equal to 36 pi x square minus 16 pi x square, 20 pi x square, okay, that is the growth, delta A let me call it, percentage growth delta A by A1 into 100. So this is 20 pi x square divided by 36 pi x square into 100, x square pi, they both are cancelled out, you are left with 5 by 9 into 100. Okay, that is 500 by 9. Okay, so let us see how much is the change. Percentage growth in the surface area of the nucleons. 36. Okay, R1, 2. This is correct. This is also correct. 3. 2 by 3. Then 4 pi R1 square I took. 4x square, 16 pi x square. Then 9x square. Okay, 3 square of 3x. 36 pi square. That increase, that growth in the area. Okay, that growth in the area is 20 pi x square. It is correct. Okay, initially it was 16. Okay, so here is the mistake I have made in calculation. You can write 20 pi x square divided by 16 pi x square into 100. Now you will get the correct answer. 20 by 16 into 100. 4, then 25 here, then 5 here. It is 125%. Okay, so I'm getting this 125%, but there is no option given with this 125%. Let us see this. Okay, let me move to the next question and I will come back to it. The electric current in the circuit given as I equal to I naught small t into divided by capital T, the RMS current for the period t equal to 0 to t equal to capital T is. So for that you can just calculate the average value of I square, which is given by I square dt divided by this time interval over which you are calculating this integral. Okay, so from 0 to 2 pi, suppose I am taking this, okay, or suppose from 0 to capital T, this is the period. Now you can write this I square. Okay, now you can write 0 to capital T. In place of I square, you can write I naught square small t square divided by capital T square divided by this time interval, which is again capital T. If you integrate this, you are going to get 1 by t cube, 0 to capital T, okay, small t square dt. Here is I naught. And now you can write this average value of I square is just equal to I naught divided by t cube. Okay, this will give me t cube by 3. Okay, so this integral is going to give me capital T cube by 3. Okay, so capital T cube by 3. That is I naught square divided by 3. This is the average value of I square. If you take RMS current is just the square root of it. If you take square root of it, you are going to get I naught divided by square root of 3. So I naught divided by square root of 3 is the right answer. Next question. When both jaws of a vernier calipers touch each other, 0 mark of the vernier scale is right to 0 mark of the main scale. Fourth mark on vernier scale coincides with certain mark on the main scale. While measuring the length of a cylinder, observer observes 15 divisions on main scale and fifth division of vernier scale coincides with the main scale division. Measured length is in millimeter. Okay, how much that is in millimeter? Okay, so according to the question, both jaws. Okay, so you can write here, suppose 1 millimeter, main scale reading is not given, I am assuming it to be 1 millimeter. Because the mark of, okay, so when both jaws of vernier calipers touch each other, 0 mark of the vernier scale is right to 0 mark of the main scale. So suppose this is the main scale here and this is the vernier scale here. 0 of the vernier scale is this, 0 of the main scale is this is towards right. So this kind of 0 error is actually a positive 0 error. So to write the total reading, you should write main scale reading plus vernier scale reading into least count minus 0 error. Vernier scale reading into least count minus 0 error. What is that main scale reading? 15. Okay, so 15 millimeter. Vernier scale reading. Okay, so how many of them? Fifth division of vernier scale coincides with main scale. So 5 into 0.1 minus 0 error, that is equal to 4 divisions of vernier scale. So minus of 0.4. Now you can write 15.5 minus 0.4, that is equal to 15.1 millimeter. Okay, so this is equal to 15.1 millimeter. 15.1 millimeter, that will be the answer. Next question. Two wires A and B made of two different materials of length 6 cm and 5.4 cm respectively, and areas of cross section 3.0 into 10 raised to the power minus 5 meter square and 4.5 into 10 raised to the power minus 5 meter square respectively are stretched by the same magnitude under a given load. The ratio of the Young's modulus of A to that of B is x to 3. What is the value of x? So you know that Young's modulus is actually equal to F by A divided by small l by capital L. What is that small l? Change in the length on applying the load. F is the load, F by A is the stress. Using this, you can write Y is equal to FL divided by, okay, Y is equal to FL divided by A into small l. Small l is actually equal to FL divided by AY. Using this, what you can do, okay, so the ratio of the Young's modulus is this. Okay, let me write the Young, okay, only let me write up to this part. Now you can write Y1 by Y2. If I write Y1 by Y2 as the Young's modulus. So they have given load is same. So load will be cancelled out. You are left with L1 by L2. Okay. Lengths are different. Cross-sectional areas are different. So you have A2 by A1. Okay. Same magnitude. They are stretched by same magnitude. That is a small L. Change in length is same for both of them. So L1 by L2 into A2 by A1 you will do. L1 is 6. So 6 divided by 5.4. A2 that is 4.5 into 10 raised to the power minus 5 divided by 3.0 into 10 raised to the power minus 5. So this is 1.5. You are now getting 6 divided by 5.4 into 1.5. 1.5 is 9. So 9 divided by 5.4. So this is 90 divided by 54. Okay. Now you are going to get 10 divided by 6 or 5 divided by 3. If you make a comparison with x by 3, x is actually equal to 5. Next one, 10 kg of ice at minus 10 degrees Celsius is added to 100 kg of water to lower its temperature from 25 degrees Celsius. Consider no heat exchange to surroundings. The decrement of the temperature of water is. Okay. So in this process, ice is going to get the heat. Ice is going to gain the heat while that 100 kg of water is going to lose the heat. Okay. So heat loss, let me calculate, right? Q loss. First, let me write heat gain by the ice. Heat gain, that is equal to, suppose that temperature becomes T. Okay, I am assuming that temperature becomes T. So first of all, we require the heat to make the temperature from minus 10 to 0 for the ice. Okay, so mass of the ice, I am directly writing here. Okay, mass of the ice into specific heat of the ice into that temperature difference. Okay, 10, because temperature is increasing. Plus another term will be there. Now heat will start changing, ice will start changing its phase, Mi into L. Okay, it will start changing its phase. Now it is changing the phase, temperature is 0 degrees Celsius. Again the temperature is increasing, it becomes Mi into SW now. Okay, now it has become water. T is the final temperature, suppose. Mi, that is just 10. So 10 into SI, okay, where is that SI? Specific heat of ice, 2100. So I can write here 10 into 10, that is 100 into 2100. So 210020 more, okay, with it. Mi, that is equal to 10 kilogram, and the latent heat, okay, latent heat of ice. Latent heat of fusion of ice is 3.36 into 10 raised to the power 5. So let me multiply this by 10. So 3.36 into 10 raised to the power 6 plus mass of ice again, which is 10, and the specific heat of water. The specific heat of water is 4200. So 4200 into T. Okay, that is the total heat gained by the ice. What is the heat loss by the water? That heat loss by the water is just mass of the water into specific heat of the water. Initial temperature is 25 and it is being dropped down to T. It is being dropped down to T. Now you can write mass of the water present is 100. Specific heat of the water, specific heat, that is 4200. 25 minus T. Okay. Put both of them equal. If you put both of them equal, Q gain equal to Q loss. Q gain equal to Q loss. You do that. What you are going to get? 21. Okay. So there is some calculation you need to do. Plus this 3.36 into 10 raised to the power 6 plus this 42,000 T, and this comes out to be this 100 into 4200 into 25 minus T. Okay, 100 into 4200 into 25 minus T. Okay, if you calculate it, okay, so on calculation you are definitely going to get your answer, and that answer will be 10. Okay, so yeah, that answer will be 10. If you calculate that, you will get the answer of T. Okay, you will get actually the T equal to 15 degrees Celsius from it if you calculate. Okay, and what they are asking, the decrement. So temperature has been decreased to 10 degrees Celsius. Next one, two circular discs of radius each 10 centimeter are joined at their centers by a rod of length 30 centimeter and mass 600 gram as shown in figure. If the mass of each disc is 600 gram and applied torque between two discs is 43 into 10 to the power 5 9 centimeter, the angular acceleration of the disc about the given axis AB is. So first of all, about AB, moment of inertia of the first one, then the second one, and for this rod. Okay, so you can write I1 that is just equal to about this diameter 1 by 2 into small m into r square. I am writing first in the symbolic form, m d1 square. Okay, plus m d1 square. Mass is same for all of them. Then I2 you can write, I2 is equal to, okay, 1 by 4 here, not 1 by 2. About the diameter 1 by 4 meter, 1 by 4 into m r square is the moment of inertia for a disc. Then you can write for the second one. For the second one, it is 1 by 4 into small m r square, okay, plus m d2 square. For the rod, moment of inertia you can write as ml square divided by 12 plus mx square. What is that x? Here will be the center. Okay, so moment of, okay, so this x is actually equal to 5 centimeter. X equal to 5 centimeter. Midpoint is at 15 centimeter from one of the end. But this axis is going through x equal to 10 centimeter from one of the end. Okay, so mx square. Now you can write the total moment of inertia. So if you write this total moment of inertia, I1 plus I2, that is going to give me 1 by 2 mr square. M plus m into d1 square plus d2 square. Okay, plus ml square by 12 plus mx square. And if you now put all the values, what you are going to get? So 1 by 2 into small m is 600. Small r, okay, that is 10. So 10 is 10 square, that is again 100. Then small m, that is 600. Again d1 square plus d2 square. So 10 square plus 20 square. 10 square is 100, 20 square is 400. So you can get 500. Okay, then you can have 600 into 900, which is the square of the length, divided by 12, plus 600 into x square, which is x is actually 5, so 5 square is 25. Okay, 25. If you calculate now, okay, so this is 300, right? So you can write total moment of inertia I. How much is that? 30, okay, 30,000, that is the first term. Plus, all they are in gram centimeter square. 6 into 5, that is 30. Okay, so this will give me 3 lakhs. Okay. 0.3. Okay. Now you can have here, this will give me 50 into 900, that is 45,000. 45,000. And this last term, okay, this is going to give us 2500, okay, 150, then, okay, plus 15000, okay, this is 60, this is 30, 90, so the total moment of inertia, that is 3900, okay, 00 gram centimeter cube. Now according to the question, torque is actually given to us, that torque is 43, okay, that torque is 43 into 10 raised to the power 5. So 43 into 10 raised to the power 5, moment of inertia, that is 39 into 10 raised to the power 4 into alpha. If you calculate it, that alpha comes out to be 430 divided by 39, which is approximately equal to 11. Okay, 11. So 11 will be the right answer for it. It is approximately equal to 11. In this way, you can easily find out the answer. Okay, some calculation is there. Do that carefully when you find such kind of questions in the exam. For the two cells having EMF E and internal resistance R, the current passing through the external resistance 6 ohm is the same when both the cells are connected either in parallel or in series. The value of internal resistance is small r is. So when they are in series, you can write equivalent EMF as E1 plus E2. Okay. So what they are saying, the current passing through the external resistor 6 ohm is same. Okay. Be they are in series or they are in parallel. Okay. So suppose there is okay, this is E, this is E, they are identical R, this is 6, current I1, that is equal to twice of E divided by 6 plus 2R. If they are parallel to each other, okay, connected with a 6 ohm again, 6 ohm. So here it is E, this is R, this is R. Equivalent resistance in this case is actually equal to E1, E by R plus E by R. You remember that formula, E1 by R1 plus E2 by R2 divided by 1 by R1 plus 1 by R2. So twice of E by R divided by twice of R, it is just going to give me E. Current here now, I, okay. What about equivalent internal resistance? They both are in parallel. Okay, R into R divided by 2R, which is R by 2. Okay. So current through this circuit is equivalent resistance E divided by internal resistance plus external resistor of, okay, external resistance, okay, E divided by R by 2 plus 6. Now according to the question, both the currents are same. So if you put both of them same, 2E divided by 6 plus 2 into small r, that is equal to E divided by this R by 2 plus 6. So E and E cancelled out. Now you get R plus 12 is actually equal to 6 plus 2R, and you can have now R equal to 6 ohm. This is the internal resistance. Next one, 2-point charges 1 nanocoulomb and 2 nanocoulomb are placed at the two corners of equilateral triangle of side 3 centimeter. The work done in bringing a charge of 3 nanocoulomb from infinity to the third corner of the triangle is, okay, and you have to find that work done in microjoule. So suppose there is an equilateral triangle given to you initially. Two charges are given, Q1 and Q2. Okay, initially. So initially that potential energy of the system is K Q1 Q2 divided by the side, suppose that side is A. In the second case, Q1, Q2 and Q3, these are the three charges capped at the vertices of this triangle. Now you can write the potential energy of the system is K Q1 Q2 divided by A plus K Q2 Q3 divided by A plus K Q3 Q1 divided by A, and now if you take a difference of them, that difference will give you the work done, and it comes out to be K Q2 Q3 divided by A plus K Q3 Q1 divided by A. Now you can take K by A common, you can take this Q3 common. Okay, so you can write this work done is actually equal to K Q3 divided by A into Q1 plus Q2. What is that K? K is 9 into 10 raised to the power 9. What is that side? It is of 3 centimeter. So 3 into 10 raised to the power minus 2. Q1, okay, that Q1 is 1 nanocoulomb, Q2 is 2 nanocoulomb. So 3 nanocoulomb, 3 into 10 raised to the power minus 9, 3 and 3 cancelled out. Okay, so you are left with 9 into 10 raised to the power, okay, 1 minute, 9 into 10 is the power 9, 3 into 10 is the power, fine, okay, 1 nanocoulomb, okay, I have to also put, I have not put the value of Q3 actually, okay, Q3 is that third charge, Q1 and Q2, they both were present earlier, so 1 plus 2, 2 nanocoulomb, the third one is 3 nanocoulomb, so I have to also multiply by 3 into 10 raised to the power minus 9, okay, so what you are left with, if you calculate it, you can get this and this cancelled out, okay, 3 and 3 cancelled out, 3 into 27, 27 into 10 raised to the power minus 7 or 2.7 into 10 raised to the power minus 6 joule, which is actually 2.7 microjoule. 2.7 into 2.7 microjoule is the right answer. Now particle of mass m falls from the rest through a resistive medium having resistive force F equal to minus kV, where V is the velocity of the particle and K is a constant. Which of the following graphs represent the velocity? How you can solve it? You can actually write equation of, okay, using the second law, Newton's second law, you can write net force acting is actually equal to mg minus kV, okay. This force, this resistive force is acting on the particle. So particle is falling, weight is acting in the downward direction, this force kV is acting in the upward direction. Now net force can be written as m into dv by dt. dv by dt is actually the acceleration, which is equal to mg minus kV. Okay, now you can write this dv divided by mg minus kV, okay, into m, that is equal to dt. You can now write dv divided by g minus k by m into v, it is equal to dt. Now integrate both the sides. Velocity is initially 0, then suppose it becomes v, time t equal to 0 to t you are going, okay. If you solve it, what you are going to get? Log of g minus k m by v, that is the integral. Log of g minus k m minus k by m into v, again divided by the differentiation of this term, g minus k by m, and the differentiation is minus of k by m, okay. Take these limits varying from 0 to v, and on the right side, you are going to get just t. So you can write minus of m by k log of g minus k by m into v, okay, minus of log of g, okay, that is equal to t. Now you can write minus of m by k log of g minus k by m into v divided by g, that is equal to t. Or you can write this log of g minus k by m into v divided by g is actually equal to t, okay. kt by m with a negative sign. You can also now write this g minus k by m into v divided by g is actually equal to e raised to the power minus kt by m, okay. Or you can write g minus k by m into v, that is equal to g into e raised to the power minus kt by m. You take this towards left, so g minus g into e raised to the power minus kt by m, and that is equal to k by m into v. Okay, from this I can write v is actually equal to m into g into 1 minus e raised to the power minus kt by m. Okay, mg by k. Okay, now if you see this, if t is increasing, if t becomes infinite, this term becomes 0, velocity just becomes mg by k. If this t is increasing, this term is, okay, this term is actually decreasing. Because it is decreasing, velocity will keep on increasing, but a time will come when the velocity becomes saturated, okay. So which graph is following the trend? it is the second graph. Okay, second graph is the solution of it. Now the next question, assuming in forward bias condition there is a voltage drop of 0.7 volt across a silicon diode, the current through D1 in the circuit is in milliampere. So 0.7 volt is the drop here, okay, 0.7 here, 0.7, okay. So current, these are providing zero resistance, okay, though the current is going through it and through this also, but they are providing zero resistance, diodes are providing zero resistance. But the voltage drop of 0.7 is there. So what is the current going? Okay, this current emerging from the battery. That current emerging from the battery I, it is equal to 12 minus voltage drop across the diode divided by this 0.3 kilo ohm. So 0.3 into 10 raised to the power 3. Now you can write 12 minus 0.7. Okay, it is 11.3 divided by the 0.3 into 10 raised to the power minus 3. So you can have 113 divided by 3 into 10 raised to the power minus 3. Okay, how much that will be if I calculate? So this current I is actually equal to and this current will get divided into two parts. So I1 and I2, they both are half of I. So 1, okay, then 8, then 8, then 3, so 18.8. Fourth one, okay, that will be the right answer for it. Now the displacement of particle executing simple harmonic motion with a time period t is expressed as a function of time, and it is given by E sin omega t, where E is the amplitude. The maximum value of potential energy of this oscillator is found at t small t equal to capital T divided by 2 beta. The value of beta is, so you can write potential energy is actually equal to 1 by 2 m omega square x square. You can write 1 by 2 m omega square A square sin square omega t. Now this is maximum, okay, U is maximum if, okay, it is maximum if omega into small t is actually equal to pi by 2. So 2 pi into 2 pi divided by capital T into small t is equal to pi by 2. Pi and pi cancelled out. Okay, so you can write this t, small t is actually equal to capital T by 4. But according to the question, it is capital T divided by twice of beta. Now you can write twice of beta is equal to 4. Beta is actually equal to 2. The equivalent resistance between the points A and B in the following circuit is X by 5 ohm. The value of X is. Okay, very interesting question it is. Suppose there is a current entering through I. Okay, the same current will get out from B, exit from B. Now this current is getting splitted into two parts here at node A. Suppose current in 6 ohm, okay, that is I1. Current here obviously is I minus I1. Now from the symmetry I can see there will in the 6 ohm, okay, in the second 6 ohm of resistor, the current is I1. Okay, here the current is I minus I1, and here is also the current is I minus I1. Now at this node here, current entering is I1, current going out is I minus I1. Suppose this is I dash, here the current is, okay. Now you can write this I1. I1 is actually equal to I dash plus I minus I1, and from this you can write I dash, okay, I dash is actually equal to 2I1 minus I. This is the current distribution, and at each node you can check, okay, it is going to follow the Kirchhoff's law for nodes, okay, KCL, Kirchhoff's current law it is going to follow. Now suppose you take this path and write the potential difference between A and B. Along this path, you write the potential difference between A and B. How you can write? You can write VA minus VB. That is just equal to potential difference, okay, potential drop across 6 ohm, potential plus potential drop across 3 plus potential drop across 6. So this is 6I1. You can write 6I1 plus 3 into I dash, okay, and that I dash is 2I1 minus I, so I am directly writing here 2I1 minus I plus 6I1. That is the first equation. Then you can write again one equation, and this time you can use another path. Okay, suppose you are going through this and this, right? So using this one, you can write VA minus VB, VA minus VB is actually equal to 6 times of I1 plus 3 times of I minus I1. If you put both of them equal, what you are going to get? You are going to get 6I1 plus 3 times of 2I1 minus I plus 6I1. Okay, that is equal to 6I1 plus 3 into I minus I1. Open the bracket. So 6I1 plus 6I1 minus 3I plus 6I1, that is equal to 6I1 plus 3I minus 3I1. Okay, this you can write. Now 6I1 and 6I1 is cancelled out. 3, okay, now you can have 6I1, that is 12I1. Okay, this 3I1, that is 15I1 is actually equal to 6I. So there is a relation between I1 and I you can find out. You can write this I1 is actually equal to 2 by 5I. 6 by 15, that will give you 2 by 5. Okay, now you can just use any of the equations. Suppose I use now the second equation. So you can write VA minus VB is equal to 6 into 2 by 5 into I plus 3 into I minus I1, that is I minus 2 by 5I. So 1 minus 2 by 5, okay, that is just 3 by 5I. So 9 by 5I you are going to get here. So 12 by 5I plus 9 by 5I. So potential difference between these two comes out to be 21 by 5I. Okay, that potential difference is actually 21 by 5I. Potential difference divided by the current is going to give you the resistance, and that is 21 by 5. You make a comparison with the given x by 5, you are going to get x is actually equal to 21. Okay, so 21 is the right option for, or right answer for it. This is a numerical answer type question. Next one, the ratio of de Broglie wavelength of a deuteron with kinetic energy E to that of an alpha particle with kinetic energy 2E is n to 1. The value of n is. So you can write de Broglie wavelength is actually h divided by square root of 2m into k. K is the kinetic energy, m is the mass. If you write that ratio, okay, that ratio, the ratio of de Broglie wavelength of deuteron with kinetic energy to that of an alpha particle. So lambda d by lambda alpha. This comes out to be square root of m alpha k alpha divided by md divided by kd. You can now write a square root of mass of alpha particle, that is 4 times, okay, kinetic energy of the alpha particle, that is 2e, mass of the deuteron, okay, so it is, that is 4 times of proton, I want to say, okay, 4 times of proton, and this is 2 times of proton into energy which is E. Now you can write square root of 2 into 2, and this comes out to be just 2. So you can write lambda d by lambda alpha. Lambda d by lambda alpha is actually 2, which is according to the question n. So n is having a value 2. 2 is the right option. Next one, a solid sphere of radius 10 centimeter is rotating about an axis which is at a distance 15 centimeter from its center. The radius of gyration about its axis is square root of n centimeter. The value of n is. So suppose this is the sphere. Now this sphere, for this sphere, the diameter is this. Moment of inertia about the diameter. Okay, moment of inertia about the diameter, let me write ICM. This is equal to 2 by 5 of mr square. Now moment of inertia, okay, moment of inertia about an axis which is at a distance 15 centimeter, okay, which is at a distance 15 centimeter about this axis, the moment of inertia, let me call it I dash, is just equal to this ICM plus m into d square. What is that d? D is the distance between these two axes, and it is actually equal to 15 centimeter. Okay, so you can write here m into k square, k is the radius of gyration, 2 by 5 m r square plus m d square. So k square, that is 2 by 5 into r square plus d square. This is 2 by 5 into r square. Okay, so r, that is 100 plus d square, that is 15 square, 225. Okay, and it is 40 plus 225. So this is going to give us k equal to square root of 265. So value of n is actually 265. Now the last one. A convex lens of refractive index 1.5 of focal length f equal to 18 centimeter is immersed in water. The difference in focal length of the given lens when it is in water and in air is alpha into f. The value of alpha is, so the refractive index, the focal length in the air is given. So 1 by Fa is equal to refractive index mu minus 1 into 1 by R1 minus 1 by R2. So from this I can write this 1 by R1 minus 1 by R2, that is equal to 1 by Fa by mu minus 1. Focal length is 18 in air, mu, that is 1.5, 1.5 minus 1, which is 0.5. So 1 divided by 9. Okay, that is 1 by R1 minus 1 by R2. Now you can write focal length in water. So focal length in water, that is equal to mu refractive index of glass divided by refractive index of water minus 1 into 1 by R1 minus 1 by R2. Okay, that refractive index of glass is actually 3 by 2. For water it is 4 by 3 minus 1. 1 by R1 minus 1 by R2 is 1 by 9. So 9 by 8 minus 1 into 1 by 9. 9 by 8 minus 1 is 1 by 8. So 1 by 8 by 9, focal length comes out to be 72. If you write the difference, 72 minus 18, that is 54. Okay, that difference is Fw minus Fa, 72 minus 18, that is 54, which can be written as 3 times of focal length in air. Now according to the question, okay, this is alpha into, okay, or you can write 3 into f because they are taking focal length in air to be f. So alpha into f, alpha is just equal to 3. Alpha equal to 3. So this value is 3 and that is the right answer for it. There was one question we were discussing and some confusion was there in that. Yeah, this one. An atom, okay, here R naught A cube, okay, so R1 by R2, that is E1 by E2 raised to the power 1 by 3, 2 by 3, A1 you should write 4 pi R1 square. So R1 if I take to be 2x, R2 if I take to be 3x, so 4 pi into R1 square, R1 square that is 4, 4 into 4 is 16, this is 9, so 36. Initial area that is for 16 pi x square, then it is 36 pi x square. You can take that growth in the area as 20 pi x square and that percentage growth is 20 pi x square divided by 16 pi x square. Okay, so 5 by 4 into 100. Okay, so according to me the answer must be 125. Let me see this again. Percentage growth in the surface area. Okay, so I think 125% must be the answer, but the answer is not given here. Okay, so this is all for today. I have discussed the solution of all the questions. Thank you everyone.